Selamat siang Bapak Ibu sekalian. Hari ini kita melanjutkan dengan webinar yang kedua mengenai SYPE dari suatu rangkaian webinar di mana kami akan berusaha menyajikan secara sistematik bagaimana software SYPE ini bisa berguna buat kita semua engineering society di Indonesia. Dan akan dibawakan oleh Mr. Diego kali ini. Baiklah, untuk menghemat waktu kita mulai saja. Nanti kalau ada pertanyaan bisa ditanyakan kepada saya dalam waktu Indonesia. Nanti saya bantu untuk membicarakan dengan Mr. Diego. Okay. So Diego, this is our second seminar for webinar for the introducing the SYPE software to Indonesian engineer. Please, you can start now. Please conduct it a little bit slow so that the audience can understand what is SYPE and how useful SYPE will be for the engineering society over here in Indonesia.
Okay, good. Thank you. Well, first of all, I'm not sure if I am the presenter right now, but I'm gonna try to introduce myself first. My name is Diego Cuellar. I'm a civil engineer, and I work for this company almost 6 years ago. Well, welcome to all of you for joining us. And today, let me show you my screen. Good, thank you. Okay, today we are going to present the software SYPE 3D. And well, there are several programs who are connected with this software. So it's gonna be a set of almost 3 software, but at the same time, I can explain you step by step, slowly, by truly, about the program, how to learn the program. And also, if you have any question, please, as usual, you can use a chat or maybe send your question to our technical support department. It's free, you can use it, please. Let us help you in any case. Don't forget that if you are trying to work with the software, don't forget to send the job, and in regard to that, you can send extra information because sometimes it helps us, to guide us in the best way to find the solution. Okay, for now on, I'm going to shut the video to close the video because I feel comfortable. What I mean is to show you in full screen the program. Okay, are you seeing my screen?
Yes.
Yeah, you seeing my screen?
Yes.
Yes.
Okay, thank you. Okay, before going on with this presentation, I will invite you for next Thursday, which we are going to have another seminar regarding to the software architecture, which is the one in your left. And through our BIM environment, in this platform, you will be able to introduce the same software, SYPE 3D, as well as SYPE CAD, as you can see in the right side. And from that environment, you can continue introducing different software, using different software like a plumbery, air conditioning system, and so on and so on. So I invite you guys, I know everybody who are going to join this seminar will be in the civil engineer side, but I'm encourage you to assist this seminar because it's very important to manage or deal with different expertise, and in our environment, it will be very easy for you to interact and learn more about these new features. The program architecture is free. You have the only thing that you may have is to register yourself in our platform, which is going to be very easy. Okay, guys, I'm going to start my presentation, and first of all, I will introduce once you open the software, you will get 4 columns like these ones. The first one is the files. The second one is going to be the recent files. In the third column, you will get the user manuals, calculations, and the example. These 3 manuals, I recommend you to open and work with them because they're pretty useful. Any question you might have, maybe inside this will be the answer, but at the same time, remember, technical support is available for you anytime. In the 4th column, I am the one, Diego Cuellar. I'm registered now in this BIMserver.center, and I'm going to start a new job. Okay, going to be, well, if you want, you can start learning by using the examples. Once you click here, the examples in this box, you will download at least 4 or 5 examples that we well prepare for you to learn the software, and it will be interesting to look at it. Okay, so we go for the new one. You can give any name. In this case, I don't matter, it doesn't matter. Browse means that you have straight right now this program go straight to these directions. That's the way the program by itself, by default, are going to save this new job over here. But it's up to you, to choose where is going to be this file in the future. Also accept that. We go for the empty one. Okay, in this window, you have all the codes available. If you display this, show you, do we have different normatives right now? Maybe in the next version, could be soon, will we get the British standard? I think could be suitable for you. But in this presentation, for now, please.
American standard.
American standard. You have all choices here. It's up to you to manage with this. Right now, I'm not interested to use one of them in particular because this presentation is just to deal with the program, how to manage with them, learn a little bit about more things about the commands and so on and so on. So I set up the program with the area codes, all of them, for coal, for rolled steel, for timber, for aluminum. Okay, so choose any category. Okay. For the guys who were in the last presentation, I talk about some of these subjects, but I'm not going to get into this because it's gonna be so long. But just we are going to use the additional load cases. Okay, in this matter, if you want to introduce a new load, could be dead load or light load, you must click here, right? I introduce it. We are going to talk about this in the next job. About the wind load, we have several ways to do it. You can do it by your own, and also you can introduce a new program, which is a vertical frame generator. In that program, by default, you can choose the wind selection, the wind loads, according to the normative or your code. At the end, you will displace you can get the analysis of the straps, and those straps, finally you can export that vertical frame into the program Site 3D. Once you are inside 3D, you can continue working in the entire job and finish it inside 3D. So once you are inside 3D, you will get by default the wind conditions. It shows it shows here according to the normative how many additional load conditions. About the earthquake. So on the left side, you will notice that we have a load here for wind dynamic earthquake loading, but we are covering the static behavior. It's inside the software. We do it internally because at the end we have to
Your voice is
do
missing.
some. Sorry?
Diego cannot hear you.
How come? What about now? It's okay now?
I can hear you, Diego. Yes.
Yeah, maybe it's your computer who has some technical
connection.
problem. Okay. Should I continue?
Yes.
Yes?
Yes.
Okay. So I continue. So we have different load cases. It could be the temperature, the shrinkage, winds, earthquakes, snow, and soil pressure and accidental loads. You can add it here. Remember, the more sugar you put, the more sweeter you get. No, so remember, if you are loading these conditions, the more you get. Once you start the analysis, it's gonna take a while. No, so my advice is to try to use what you need, just what you need, not to get the best of this information. Not try not to load from information that you are not going to need. Okay, so what about almost finish here. Okay, so now we are inside the program. As you can see, we have in 3D dimension. We are working in 3D dimension. About this environment, the only things that I recommend you, 1 second, is to click here in the wall, the glove, to be sure the undo and redo selections. The maximums is going to be 20 numbers of actions, and by default you will have only 5. Okay, so that's the first thing. Now, for now, we are going to talk about 3 aspects: points, joints, lines, and also sheets that are in the software. And one thing that differs with the program SciCAD is that in SciCAD you introduce the elevations and then you decide how many steps are going to be the building. But the program is a very easy task to do it in SciCAD. But in this program, you must introduce this reference. You have to use the level side. You have to start with the ground level, then you start with the first level, and so on and so on. You have to create it yourself. It's not the same like in SciCAD, but it's easy to manage. About the knot, for example, I'm going to use a new knot, a new knot, and I can click 0 by 0 by 0, and you get straight to the initial, or we call the origin. It's important to know that your origin is like this. For now, you can start doing something else. That joint, you can displace, you can use the external physicity or internal physicity. You go for the external and click there. You have several options. This external could be the physicity, which is full embedment, you can decide in which direction you are going to allow them some kind of freedom. At the same time, for the one at the bottom, which is called the pinning connections. In the pinning connection, at the same time, you have on the right side different conditions that you are allowed to move in the depends, you know. And this one is free one. In this case, in this particular case, this button, this knot that I already made, is called a free one. Is recognized as a free one, and something that you can do, which is a generic one. Generic ones have several conditions about the displacements and also about the rotation. And so after that, you can start introducing a bar, a new one. By default, it gets this kind of bar. I'm going to show you how to choose the bars. In this interface, we have several options regarding to the materials. That one is the steel sections. The second one is the rolled steel plates, and the other one is the steel cold form steel. You can work with wood, with aluminum, any shape in aluminum, special aluminum sections, concrete bar, a generic sections. On the bottom, there are families. You know, if you choose the first one, you have families on the bottom. Could be this and this, etc., etc. You choose the second one. At the same time, you can display different sections. The same for the other ones. Okay, same for the other ones. So remember, if you choose, for example, to work with these special aluminum sections, once you finish the program, it will give you in details the result information according to the materials and so on. So if you are using the generic options and you want to introduce a concrete bar, these bars are not allowed to get the reinforcement. You don't get the reinforcement. But if you are using the column or the beam section selection, that means that in that area, in that part, you can get the reinforcements. That's why we introduced the first option about the elevation, because in that matter, you can control, you have a better control about the introduction of these elements. So remember, columns and beams is like a separate sections, but if you want to see the results about the reinforcements, we go back to the generic ones. Going to introduce for now this kind of beam. Doesn't really matter really. On the bottom, the layout could be simple section, could be hinge, with concrete slabs. And something that I like a lot is not this one, is that one, the castellate profile. You can use the hexagonal one, the octagonal one, and the circular one. All right. So also we have some very, very particular one. I think it's over here, which is the with variable section. I'll show you later one of the frame that is already prepared for that options. It's very special, but it's available in the program. In this grid, if you click here, perhaps what you are looking for example, you need to introduce or to look for any fabricator. So is this section, look the shape that you are looking for, and on the bottom, if the window displayed something similar but in red color, like we are here right now, that's mean that you are going to have a different fabricators. You can choose whatever you want. in this example, particular example, we don't have the American standard, so it's like that, right? Also, if locally you have some fabricators and you are interested to have this information in the software, you have to send us, and you can call the company and ask for the profiles and manuals, etc., and send them to us, and we'll be introduce it for the next maybe next software, next actualization. All right, so I'm going to continue with this. Remember, the grid is like here. Look, we have several options. Now you can use the American standard. You can use the profiles, the American profiles, because perhaps you manage in your country that way. Okay, so I'm going to continue with that section, simple section. Sorry, 1 second. Let me see. Okay, good. Check the resistance. Well, I know something's wrong. Okay, so you can start from here. Remember this option. You can play with that, but you can go straight in the column using the orthogonal command. So you go straight. When you click anywhere, you can introduce the height. This is the length. I'm going to do it 14, for example, and then you can go anywhere, right? Sometimes, well, I prefer to work in 2D, and but before going that, I will show you the basic stuff about the columns. Let me show you. I already have these loads introducing for you. Okay, we have, for example, I'm going to show all of them. This is the basic knowledge about the software. On top of the column, I introducing different loads conditions. So we are going to see how we introduce the load first. We go for project, general data, in additional load cases. I introduce 5 live loads. All of them are here. One's Q1, Q2 in the X direction, Q2 in the Y direction, Q3 is a moment, Q4 is a moment, and Q5 is a temperature, right? So there is one condition, and perhaps I'm going to use a new one, Q1. Yeah, on the bottom you have with different load disposition, and this new disposition, like compatible. You know, when you are playing chess, you have black and whites. So when you are using these options, it's like the loads are considering in one time with any combinations in the white sections. In another combination, they are going to do the opposite. They are going to introduce the load in the black conditions, the black case, and so on. It's like when you are crossing suppose you are crossing a bridge, and in that bridge, in this software, you can do that, but we don't have mobile or dynamic loads. So that's in this way you can introduce several load conditions on top of on the bridge, and in using compatible, the software are going to work and play with these conditions until they will get the worst case scenario, and they will display the right information according to that selection. And the other one says it is uncompatible, and other ones simultaneously. So, well, I'm gonna cancel just Remember, the more thing that you add here, the program are going to take long time, to do the analysis. Try to be precise, and that's all. Okay, so we go for the conditions now. About the loads and the visibility. For example, I'm going to display not only the Q1, just the Q1. This is the load Q1. And now in the analysis, sorry, not this. Yeah, we can run the analysis. Okay. It's pretty simple. Now, whenever analysis is done, I can look for the, well, first of all, I'm going to show you the conditions. Go for the Q1s. For example, for the Q1, we go for the load conditions in the bar. Okay. So we go for this one, which is the Q4, I think so. Yeah, Q4. Q4 is it's a moment. It's a moment. The value is 4 tons per meter. It's a related position. It's in 0. And the distance. And also we have a different reference. We have a global reference, which are in the bottom to your left over here. And the red color means X directions. The green color means Y directions, and the theta is going to be blue. But we have two reference, the global one and the internal or particular reference, which is this one. The bar by itself, you can see here, have a different colors. That's called the internal reference of the bar. So once you have noticed that you are clear about this reference, on the bottom you can choose which direction you are going to take. In this particular case, I'm choosing the X direction in the axis X. So we are using global reference, and you can also look. You can do the local or local axis of the bar, whatever you want to go. Okay. I manage better to go for the global axis. Well, we go for example, for the next one, like this one. Right click, choose the drawing, and then the right click. This is Q3. Q3 is apply moments as well. 3 tons. The value is located in this position, 0 position. The reference is the global axis, and I change the direction. All right. But about this point, number 2, right click. The Q2 is a local point load. Relative position is about 3 meters. The global axis, I'm using this direction. All right. And what about the one? No, this one. Let me see. That one is another point. Type of load is 1 ton. It's on top of the column, and the direction is going to be like this. All right. Okay, so once the analysis is done, I can go for the first of all the check element sometimes. So if it's in green, means that the profile that I chose is okay. This is the range that the profile is working. We do the first selection. I can go lower than 200. I'm using the HEB profile, but I can go lower than this one. And the ones that you are seeing the screen in red color means that it's not doesn't fulfill the requirements of the solicitation that we have in the bar. All right. You can go also for the deformate shape. In the format shape, you can introduce the structure by itself, and then you can go for the combinations. Could be the simple load case, which are not affected by any coefficient. We go full safe weight and all the load cases that we already had. I'm going to increase this factor by 200 just to see well. Going for the Q1, and I'm going to see an animation of that bar. So remember, Q1 is the one in the X direction, and this is the effect of that force. All right, so we go for the Q1, Q2. Q2 is almost the same thing, almost the same. Okay, you can see it in this way. You can turn a little bit. You know, it's another direction, so it's a very nice options to see what's going on with the structure. That one doesn't do any effect because it's a Q3, and then the Q4 the same, and finally the Q5, which is nothing. Okay, it's nothing. The temperature, I think, which I chose temperature and doesn't show anything, any reaction. All right, you go back here through this window in this small book over here. Click here, and you go back to the same screen. So now I'm going for another example. This example is a very simple beam. I'm sorry. Sometimes I'm going to use some documentation. Some of them are in English, and other ones, unfortunately, I don't have time to. I didn't have time to translate it, to do the translation. But please forgive me for that. Accept my apologies, and I will for the next presentation we can do better. Okay, and no, I'm sorry guys, but I'm gonna hang up. Okay, yeah, for now on, we are going to talk a little bit more about this, about the bracing. We are going to use this kind of the reference, like, 1 second. Yeah, on here. We're going to use Purlins. We're going to talk about the cold rolled beam. In around, this side we have as side rolls, rafter. We are going to talk. I'm going to change for rafter for beams. Columns. I'm going to use columns. This kind of new information you will get it, but sometimes I'm going to use one another. So, okay. This beam, I do the same thing. I create some kind of loads. Could be Q1, dead load, and set weight. I'm going to do it, all of them, to view it. So that loads create different reaction in that beam. And what I mean is that, 1 second. Okay. This for now on, we are going to talk about the reactions or solicitations and deformation. That we're going to talk all the times about this, about the reaction in that beam. Everybody knows about this kind of formulation, but I'm not going to talk about that. Just to show you that about the reactions, we are going to have stress. We are going to have moment deflections. Flectors, and the ones we want to have turned and elastic evaluations. Moment deflection, maximum deflection. That's it for that. We're going to talk later about this. Then the reactions that we are going to see in the analysis about this shape is going to be similar. So we go clear. According to that load, this beam is okay. We can go on with this, and the other in the extreme is going to be okay. Remember the coactions. I'm going to show you the coactions. It's going to be external ones. These ones is the pin connections, and we had some restrictions about the displacement. And the same for the other one. Same for the other one. So at the end we have that one is the free one. This cantilever, the condition of the cantilever changed a little bit. I will show you first the analysis and the deformation shape. Okay, according to that, going to increase this value for maybe 300 or more, and for the dead load. For dead load, look, that is what is happening. That's what happening in the column, in the beam. Okay, this is deformation shape. Same thing for the Q1. All right. This is the normal behavior of that column or that beam, but allow me to see in a better way the entire structure, how the structure is moving, and I will correct or fix something which are not well connected in the structure. So we go back to this case. So now we are going to talk about the backlink. First of all, not the backlink, about the limit definitions, the deflections. I can create deflection group. I have to select 2 points, and I already have this selection. But if I get a new one, the program will display something like that. In this case, this is not the right way to do it about this scenario, because we have a cantilever on top on the right side. So in between the knots, between the articulations, we have something that we call secant, and at the end, from the second point to the free one, you will have something which is a tangent. So we have to be clear. Let me check. We have to be clear about these conditions. I'm going to edit the group. This one is, as I told you, secant value in the X and Y plane, and in the X and theta plane are secant. It goes like this, this like this, something like that. And the other side is the condition is tangent to the knot one. But we have to have a reference from this side, because at the end of this, or at the extreme of this bar, we have a free point. So we, in order to select the tangent condition, we must have a point of reference. In this case, is this point or the reference. That's why you call it N1 and N2. You don't see it right now because the color is different, but you will notice that we must change the conditions. In cantilever, it's different. Okay, this is the knot N1 and knot number 2. What else I can tell you about the bars? You can also create your limits according to the normative, right? We go now for the lateral backlink and lateral backlink. Okay, so we go back to this document about the backlink. So for the lateral backlink, we can select well, first of all, we have to talk about the formula. The formula is called LP equals B, which is the value, this value, and LA is the length of that segment. You can every length or every conditions according to the coactions that we are taking in considerations, we have a different value here. Okay, if we go for the value and we select the value, this coefficient, the program are going to do it internally according to the length of the bar. But if you go for the last one, which is the length, you will have something different, because suppose you have a strap, a strap over here, and the strap, according to the spacement between the straps, that part, on top, the profile will be embedded or restricted, and in that area is better to use here on on top the length of the spacement between straps. That's the right condition, because that's the way to work, because you are not going to have that backlink effect in that area. So from the bottom, because this is the top flame, on the bottom flange, you have to introduce the entire length of this raster. Suppose the raster is 4.8 meters, so the second condition are going to be 4.8 meters. So that's all about this part. Okay, we have also several conditions, but we go on with the presentation. Okay, so continue with the lateral backlink. You see that's called the lateral backlink. We go back to the selections depending of the conditions. In this case will be something like this, like simply superposition. If we go for the last one, especially on the roof of this warehouse. Okay, and the cantilever is something similar. You have to choose the conditions. About the critical moment, I'm going to use, indeed, allow me to do something. Let me check. Give me one moment, please. I had two windows, so two screens, so I have to look for one of them. Let me see. Okay. Well, it's in Spanish, but don't worry. This is backlink. These coefficients, who are going to, well, it's not well. The next screen you will have the backlink conditions. So these values, these coefficients, are regarding to the moments or diagrams. Those values are almost in a range of 0.9, 0.95. But if you want to be precise, you can change the value. By default, this value is 1. But if you want to be precise and you know what you are doing, so you can introduce, according to the diagrams, these factors, these coefficients. It's around, as I'm telling you, it's around 0.9, 0.95. So it's where up to me. I won't do it. I will keep it that way. In that case, you will be safe. Okay. Same thing for the lateral backlink. Is the way to do it in here is like this. The factor conditions, the critical factors, CO1, are according to these tables. So don't worry about these factors. If you keep it 1, it's gonna be safe. All right, so I think this is it for this part. in this place and the analysis. I did the check ones. Well, we can continue with the other ones, the next examples. Okay, so we go for our our initial conditions, right? So I'm going to continue right now with something that we how to work and how to introduce a warehouse in an easy way. We have several options. The ones I'm going to use are going to be easier. It's better to work with windows. I'm going to open one of them. In this case, it's going to be rectangular in that plane, orthogonal plane. So I have to select first the vertical bar and then the side that I'm going to work. I'm going to use the theta y plane. If you want to call it, I'm going to call it theta y plane, or maybe frontal frame or whatever, right? So it's going to be my first one. So for now on, I'm going to continue into screens, yeah. Let me check the bar. I'm going to continue in what menu bar. So I don't really care where to click, I can do it like this. I'm gonna accept that as well. And also remember that I'm using the orthogonal commands. So I can display now everywhere. You can click everywhere. I accept that as an okay. Sorry, it's okay. I'm going to go back. I did something wrong. And finally, I finish here. Okay, so now we have a command, a very nice command, which is called the tools. We go for tools, and then bar and knot. We go for knot. Then we go for codes. Okay, planes, dimensions. So in added, and then we can introduce the length that we want. About the distance between lines, I'm going to introduce 10 meters and generic the dimensions. Accept that. So you can click between, for example, between here and here, and the software are going to arrange that 10 meters. Now you are in the same commands. You click in the other side using the same command, and it's already done between in the vein. The vein is going to be 20, but it's going to be like this. Now I'm going to change that with the right click. You go back to the command. I'm going to introduce 5. 5 will be the distance between this and this. Is going to be the height of the warehouse, the first frame, and then right click 0.8, which is going to be from here to here, and the last one is going to be 1 meter. You can call here 1 meter and click on top, and then in the second one, now we get it right. So these are the new conditions for my warehouse. and then I can start working on it. So I continue with the same bar, new one, from here up to here. Okay. And I need to use a different command right now, and this command is we get it through tools and generations and also planes. If you click from in this point up to this point, you have, no, I'm sorry, generation, tools, generations, nodes and bars. I'm sorry, nodes and bar. Clicking the extreme and the other side, you will see number one. Click the right, click on the number. It gives the number of sections that you are going to use. In this particular case, I'm going to introduce 12 separations, and the program divide the bar in 12 sections. On top, right click. Yeah, now I'm going to introduce on top. On top is going to be something like 6. Sorry. We go back. I'm sorry. We go back to the same command. I go for the tools, generations, nodes and bar. Click here on the other side, and then right, and the next number is gonna be 6. Like that. Continue with the same command to the extreme. Right click. It's number 6. All right. So we can continue with the same bar. By default, it displays IPA. So I'm going to go a little quickly. And then the other side. You know, as we go on with the introduction, you will see different lines. Those lines are reference. And if you go faster, maybe you get the wrong side because of that. You know. So now, the next step is to use groups. In bars, we have to use group. I'm gonna group the one on top. Well, this one is gonna be different. I can select. Let me see. I can select like this. All this group. Okay. Right click. Say yes. And now the one on the corner, because are going to be different. And these two bars are going to work the same thing. Okay. I forgot to select the external Physicity on the bottom. I'm going to use the Physicity. Okay. On top, if I displace that, look, internal Physicity means the nodes, all nodes on top. If I display this with the right click, you can create different conditions. The ones you give some coefficients. This is free, and this one is a generic one. So we go for the first one, which is the fixed node. Okay, the program by default are going to use that. So now if you touch a group, if you go for group, if you touch it, you will displace the groups. Okay. So now it's better to go back to the 3D view. Yeah, here from the 3D view, I'm going to use to generate the same frame certain distance. So you have two ways to do it. One way is to go back to the tools and say use the copy commands. You're going to copy the nodes on bars. You can select all of them like this, then click in one of the corners, right click, and then click it again, and you start moving the entire structure anywhere. Okay. If you want to be precise, use your orthogonality. You see you control in a better way the displacement. Okay. Now we have another condition, which is we got it in tools, and it's called generations and planes. Now we're going to use planes. So we click, for example, here. We click here. You have to be precise. You are clicking the wrong way. So now you can the number of planes to generate of veins are going to be 4, and then separation between them is going to be 5, and I'm not going to group them. Okay. Oh my goodness, I did it wrong. 1 second. So I'm going to do this again. 4, and this one is going to be 5. Okay, good. Remember, you have to group them. So go for groups, always groups. So this group, the front particle and the dorsal particle, according to the loads selections, are going to have the same results. So I prefer to select these two groups as one. These ones are going to select that one as well, and the internal are going to be different. Okay, so these and these and these are going to be another group. The one on top are going to be another group. What about this, that, another group? And sorry about this over here. Until we got it all, you can, well, it's missing this one. Okay, so on the bottom, click freak, and the one on the bottom like this. Maybe you're thinking why this guy is using a group. Group is really important because suppose you have different loads on the roof. According to the location of the bars, some of them are going to require more solicitation. So as a group, the program are going to do the best selections according to the profile that are available in the software. So that's the objective to use group. So we continue now with another window. We go for open a new window, the same theme, orthogonally. So we can select this point, this bar, and then the one on the bottom. Always give it a name. This is maybe the left side. Okay. We continue with the same bar. New bar. Before doing this, select the command, the bar command. On the bottom, you have generate the nodes at international points. That means that if I cross for example, this point, automatically they are going to select the joint. So like this. The one at the bottom. Okay. So I'm going to, what else I need? Okay, I need to select the points on top. So we go back to the commands, tools commands, generations, and nodes and bar. I'm going to click here up to the end and right click, and it's gonna be 16. Okay, on the bottom the same thing, 16. So now it's that this pin are going to control the wind in that side. What else? Here from here, the bottom, 3, just 3 knots, and divide it in 3 veins. Okay, continue with the same bar. So wait, sorry, it's gonna be like this. I'm gonna make a close up from here. I'm going to navigate the orthogonality. I already had that one. I call this agility. Don't worry if you don't manage this first time. If you do it 1, 2, 3 times, you will get it. I don't know if you know an expression. You say, if a fool persists in his foolishness, sometimes became wise. All right. So another one from this side up to here. Same thing from the bottom. Okay. So and I will select the groups. Remember the groups? So we go for groups. We go back for groups. I'm going to select not the one at the corner because I already had that one. All right. So another group, the one on top. That's another group. The one in the corners already has a group. The one internally we have a group. Those are in a group. The external in the group. So I'm going to do another one. Okay. You will notice that there is a red color, dark color in between. That is because we have considering right now that the bar is a full bar. It was made that long from the factory. So using the bar, we can ungroup. No, sorry, we can create an element. Create an element. You must click in the first knot and the second consecutive knot. Say yes. You notice that this became it's like you have sections of that bar, the same bar, section of the same bar. This is the right way to do it. All right. I'm not going to do it with the column because the columns is going to be like this. Then you can use different elements like, you know, you are going to reinforce in different way using the different bar. We go for a new one. Okay. look this one. I'm going to use the type section, the type bar, the round bar. We go for the 10 one. I don't really care. It doesn't really matter. If you want to know more about the method that we are using here, you will displace this document. It will tell you details about the method that we are using it. This kind of bar are not allowed to they're not allowed to work in compressed sections. It's always in tension analysis. So this is the method. Accept that. Before start using this, I prefer to disable the generation of knot. I don't want to generate knots in between. So now I can go to the streams, just to make sure that in the center I'm not going to get a knot, because this is not the right condition. But the program by itself creates a different bolt connection in here. The same for the extreme. Okay, so remember groups, always groups. I insist. Okay, yes. Once I divide the bar, it was unselected as a group. Okay, then it's done. So we go back to the 3D view now. And in this case, I'm going to move all these elements to the other side. So we are going to use another one command, which is in planes. Groups in the plane theta, x theta. All right, accept that. So click here and then click one more time and then move to the other extremes. Click again in the right click, say yes, and you got it. Okay. Now it's okay. Now I finished with this. I will display also the group just to make sure that it's working. Yeah, it's working. Okay. So now we go for the roof. Going for the roof, I must create another Windows. It's a new one. But in this case, you have a slope. You must go for the second choice. Well, sometimes it's better to get rid of this mess, the mesh. The way to do is go back to node, planes. We call it show and hide planes. In this case, I'm going to hide them. Select all the points like this, the right click, and it's gone. Then we go for the Windows, the 3D view, the 2D view. Select 3 points on top. Give a name. Could be I don't know, left roof. Right. Same thing. We can continue with the introducing the bars. Same bar. Well, we go for the generate the knots. Don't forget that. See all of them. I'm doing the straps, Already know that the straps are going to be located on top. And okay, that's okay. Now I can use the sorry, create elements. Also create elements here. To consecutive point. Right. Don't forget to use the groups commands. The last one, I'm gonna keep it for a different group. I'll show you how. Like this individually, right? Now we go for the same selections. We continue with with this one. You can come back here, or maybe you can use on the bottom. The bottom, if you click on the bottom, you have two selections: the IP80 and the 10 diameter. So remember to select the generated knot. So we go from here up to here. All right, I'm doing okay. On the other side, the same thing. Okay, good. Group, remember? Group. Right side, yes. Okay, now we have to make sure that that everything is going to be in the right place. Where the straps, for example, this view is called active view because it's only part of the structure. So we go for the active view, and look, I made a mistake. I was introducing. Well, this is gonna be. I have to change the bar. I'm going to describe this group, which is the wrong one. I'm going to use the IP80. Okay. Now we go for you see, the 3D view helped you a lot. You know, I was doing some mistakes, but I'm using okay. So now the straps has to be on top. And also the straps are not, are not well located. They have a different slope. So I must correct that. In order to do so, we must go for the bar is called describe this position. So we go for the group, select the group. All right, right click. To do it properly, you must click in this button, which is calculate the relative rotation angle to the active window plane. Click once. Don't forget about this. Accept, and it's rotated already. And also the center of that profile is here, but you can play on top, you can play on the bottom, and look for the best location. Now I'm going to, sometimes I cannot figure it out in my mind where is the location, so I have to try it out, mistake and error, and accept it. And we go back to the 3D view in the active. So we go straight, sorry. So now it's missing a little more, you know, it's almost in the middle. So I need to go a little farther. First of all, I need to know what is the length, what is the dimension, the right dimensions of that bar. Okay, here. So it's going to be 80. So half is going to be 40. So we go for the bar description, describe this position. Right click. And now we go for the 40 millimeters, 40. Could be globally or locally. Okay, I'm using locally. If I click enter, so the last check, look, that's the right position. The straps, you know, according to, look, in this case, the purlins, or you call it straps, the purlins, if you are using the particle frame generator, it gives you exactly the right purlins and also the best separation of these purlins. In my examples, I already had it, but the right way to do it is like this. Once you are in inside 3D, it's up to you to introduce that one. If it's not, it's not important. You need to introduce it because you want to show the clients some details about the job, about the work, right? Okay, so continue with the other side. We go for the 3D view. I'm going to introduce the last one, analysis of the window. Open a new one, select 3 points. Sorry, I did it wrong. I'm gonna cancel because I did it wrong. This is the right side, right roof. We do the same. 80. Purlins are really to do it right. It's gonna be a little difficult, but with this program, it's gonna be easier. A bar, create an element, 2 consecutive points.
Can you just copy that one, Diego?
To copy, well,
on the left, right, direct.
No, if I copy, doesn't copy. Oh well, yeah, could be a solution. Okay, it's done. Bar group. Okay. Okay. The last one. Remember, that's okay now. You see, the copy command will be a nice option as well. You hear, everybody can find a better solution, a better results. This is my option. This is one option. To teach this software, you must concentrate and repeat the same actions all the time, you know, until people can get it. It's gonna be boring sometimes, but that's the only way to learn. Practice makes you perfect, no? Okay, good. The last check, I'm going to turn it, bars, displays, describe the position. I already know the right position, so it's going to be faster. So we turn it, we give it out what it's on the bottom. It's going to be 40 millimeters. Oh no. In this case, it's going to be minus 40. We'll see. Try and error. We have to check our job. Okay, good. There is something wrong here on top. I have to change that bar. The one on top, and I'm going to do it like this. Describe, and then right click. And I'm going to choose the IP 80. One more time. Okay, good. I can put it on top as well. Okay.
Diego,
yeah, tell me.
Can we make the intersection on the very outermost of the bar with the purlins to not at the center, to lay it at the right at the end of the flange?
Sure. Yeah, sure. You're right. Let me finish with this. Like this, and 40. I guess 40. Minus 40, I think so. Minus 40. All right, it's okay. Well, perhaps it's not like this. It's okay. I need it straight because it's the last one. Okay, so I want to go up. 1 second. Let me delete this. Okay, now. Vale, okay, got it. Sorry, what are you saying? I forgot that. Say again.
The outer, you know the purlins at the when they meet at the outer bar or the outer bar have to be right at the edge. Now you are at the center.
Okay, yeah, that one, no?
Yeah, this one. How to make it to the center and to the edge.
Okay, but okay, this is gonna be the same. Like this, the bar. Describe this position. We can do it like this, for example. Try an arrow to turn this side. Go back to the active window. Well, I did it the wrong side. We go back to the plane. Sorry, describe this position. So it's going to be in the other side. Oops, sorry. Okay, good. Okay, now it's in the edge. Sorry. Okay, you got it. It's in the edge. If you want to put it on top, just to move it, okay? You can do it on top. let me see. Let's try this position. Sorry, bar. Let's try this position. On top, it's gonna be like this, and maybe 40, minus 40. I'm sorry, 40. I get mixed up, you know. Minus 40. All right. Okay, good. Now it's in the right position. Then we go back to the 3D view. Now, up to now, well, we have to group again. This is the last. We must select everything on top. Now we have to check if everything is okay according to our selections. The group. See, group on top. Well, I can this and this join together. See, all right. So from now on, what you can do is just introduce the loads conditions. The load conditions. Look, we go for loads. You can introduce the loads in the bar. If you do any manual calculations, you can introduce the load in every bar. Also, you can introduce introduce the panel, and also introduce the surface load. The panel you must go for 4 points. For example, I'm going to do it on top, 4 points. The last point with the right click, the program are going to select to finish the frame. Then you must decide which bars are going to be loaded. So in my opinion, I'm going to select these sides. In the right click, look, any loads coming from top are going to be located in this direction. So the bars who are going to be loaded are going to be these ones, this one, that one, that one, that one, that one. This is my case, no? This is my case. So from now on, I can introduce different kind of loads. If in this case I have only the safe weight, but I can do it as much as I want. If I'm talking about the wind conditions, I will create my conditions. If I'm using the particle frame generator, this will be displayed by default. Everything will be free for you. And even any dead load or any other weight conditions. And what happened is that any value that let me click. Sorry, let me go back to that because I forgot to tell you something. Edit the panel. In edit the panel, for example, for these weights, I can do, for example, 0.4. Now I'm working with the tons by meter, square meter. Accept that. There are also kind of combinations that we must take about it. Introduce this. No, here. Sorry, the limit state. The limit state. Suppose the program by itself got inside the right combinations according to code selections, But if you want to do something external, maybe you are going to do some specific studies in the foundation, and you want to know something there, or maybe in the metallic structure. So we go for configurations who are by you, doing by you, not in the concrete. Could be for example, cold form steel. Go for by default. This is the information that we got. You know. But you need something in specific, something important. So we go for the project options, click in the blue arrow and accept it. You will have the combinations that are already done in the software, but it's up to you to study and select or create your own combinations. This is the way to do it. You know, that's the way to do it by your own. But I just warn you that if you want to do it properly, some of the software go for the unfavorable conditions. We have favorable and unfavorable, but just not to get mixed up with this information, for the permanent condition like dead load, introduce here the same value. In variable condition, use the same value. For the live load conditions, just make sure that these values are going to be in the right column, the unfavorable conditions. That's all you need to know about this introduction.
Copia, what is the copia?
Sorry,
the name copia of seismic loading. What does it mean? The copia there. You see on you highlighted the blue one. The blue color. Copia. What does it mean? Or it's just copy?
Yeah. Look. We go back here.
What does it mean?
The program by itself generate this information, which I display that document. But if you want to do something on your own, you want to do your own combination, you must, first of all, my recommendation is, you know what to do it, just go straight and create your condition, your condition. But if you don't know this, it's better to know what we have by default, which is this arrow. So accept it, and that's why we have by default. That's why we call it copy. Copy, seismic loading, accidental loading. It's a copy. You can also change this. If you click inside, you can retype what is inside. There is no, because it's going to be your selections and your combinations. Perhaps you are not going to take in consideration the dynamic forces, so I don't go for that. You mean this is a dynamic force, seismic loading. So if you don't need that, delete it and do your own combination. Perhaps you are going to study this structure just for the live load and dead load, right?
Okay.
And this coefficients over here, the coefficient over here, you must understand that this coefficient you might know. You have to know these coefficients, right? Any other question?
Okay, for now.
Okay, continue. That's all. I'm going just to display that because it's important that you know that. Accepted. What else? Well, so now I'm going to show you. We go first. When we finish with this, the next step is to select the profiles. Now the other groups. So we go for the bar, describe. For example, this one, this, and all these bars. I'm going to change it. Right click for not for this kind, for the European profiles. in columns, it's pretty useful to use the HEV. We can go, for example, for maybe 300 and that. Okay, so I'm going to display in 3D view the entire structure, the entire one. You see, it's going to be something like that. But I use the first for the example. I introduce only one bar, maybe just 2 bars. But you must understand that once you have the group and you finish the structure, then you can start introducing your profiles. You can start working with the profiles and then run the analysis and then start changing or do the modifications until you get the best solution. One of the best solutions means that you might know exactly about the backlink condition. Backlink and lateral backlink are essential. It's crucial for you to know how to use it, because if you need to save money in your construction, is recommendable to use it properly, because you get the best profile. That's one thing. Another thing, like no, not this one. Let me check if I have here. Okay, the backlink is so interesting to know that you will have something like this. Maybe you have a strap here. You need some reinforcements in this size in the column. You have different kind of mistake that you may avoid it if you don't do the proper solutions. You see, you have a lot of conditions. This one, the reinforcement here works okay for this beam, but not for the column. Yeah, and they forgot to use here another restrictions area. You see, there are several cases, several ones. We must understand that in metallic structure, controlling the backlink is so essential. Well, they have different conditions. Some of these pictures I made it here in Spain. Okay. We have this in the program. This solution, we have it in the program. Okay.
So the program can provide all the detail of the connection, correct?
Sure. Oh, no, I will tell you later. We go back for that. So now I'm going to display for you. Well, I'm going to close this. I'm going to show you examples. Because I want to make sure that you understand the wind conditions, which is more important in metallic structure. I'm going to go for the aluminum. Where our example? I think it's this one. Okay, good. Look, in this loading, well, first of all, I need to go for the project. Here we have the additional load cases. When we are talking about the wind, for this example, we have 5 conditions. We have 2 in A condition. We have A positive and A negative, B positive and B negative. One in the front, and perhaps once for snow. But at the least, we have in this condition, wind conditions, we have 5. So for the light load, only one. Light load could be the snow. Yeah, could be the snow. No, here the snow is like this one. The snow is this one. Light load could be for reparation or fixing problems on top of the roof. But these are the conditions. Now, I'm going to show you one by one. The load cases conditions in Site 3D are not automatically. If you use the general particle frame generator that I'm going to use now, later, the wing conditions are automatically. So we go first for the negative one. So the negative one is like this. The user, they did it manually. Okay, they did it manually. There is something wrong in this one. Maybe there's something is particular. Maybe it's concrete. Now I'll show you the next one. Positive one. Different colors to distinguish between one another, and also the direction you will notice here. It's coming from left to right. Okay. Even inside the air conditioner, the air goes differently and affect the structure differently. If the wind coming this way, for sure will be affect differently this side of the roof or the other one. We go now for the snow one, which is the easy one. This is the snow condition and the front condition visible. The front one. You see, it's different. So now, another thing is you want to run the dynamic force, you must check the coactions. Everything around the structure has to be well connected. Could be this section, this selection, for example, the bar, the knot, the external fixity. This condition has to be in all the bars around the warehouse. In this case, we have different condition here. Look, so I must change this condition to the fixed one, because in the analysis, the program will warn you that we have some mechanisms that means that in that point you are liberated in the 3 degrees of freedom, and the program are not going to solve the structure. Inside the structure, you can have it. Inside the structure, you can have that condition, but externally, like a frame, has to be in that in that sense. So you were talking about the joints. So I'm going to do the analysis of this building, this warehouse. Sorry. Won't be long. This very small chart. Remember that the analysis is done. I'm not going to go for the check and forces. We go for the joints. We are going to generate the joints. So the program recognized 180 connections. So they are there in blue. And now we go for the analysis and design all of them. Well, you can do it welded connections or bolted connections. Now we go for bolted, but before that, this on the bottom, you have available the source of these libraries. I'm going to display the first one. They just go straight to our website. In our website, you can go down. You will see the connection that we already have. Be sure or make sure that the conditions are the same as you are recreating in the warehouse. So the solution here is a drawing. You can see it is a match with the structure. For sure, you will have the solution. Sometimes part of the knot will be welded, another one could be with welded. bolted or welded. It's not necessary to have the same condition everywhere. So the joint is going to be like this. Also, in columns, you are several steps in the structure. If you want to solve this particular joint, the top on the column has to be considered as a forgot the name. Let me check. A continuous beam support by columns. This connection has to be different. I will show you. Okay, I will show you later. So make sure first that the conditions are here. Then you can go on for the connection. Suppose that some of the knots are not well done, or you don't find a solution in 4 or 5 knots over here. So we have another software which is called SyConnect. In SyConnect, you can take from this software all these solicitations, introduce it in SyConnect, and work separately that knot. This is one thing. And we are going farther than that, because in our BIM environment, we have another software which is called the Steel, CYPE Steel. In CYPE Steel, it's just brand new, this software, and is meant to do any joint you might have. Could be any connections, any bar or combination of bars. Not only that, you can also find the profiles. You can use different formats like Tekla. You can use it in the factory, and they can cut and drill in the right way, properly, according to your according to your needs, And it's gonna be very interesting to find that once you are working with that Steel, you are creating your own library of joint solutions. So at the end, you can exchange this information to your colleagues and get growing and growing, because this is not this is an end, and this is not an ending process. Joints are everywhere, are differently. You have a full variety of joints. It's impossible to have it all of them, but with the next software, it could be available. Okay, so I'm going to do the bolded selections. Okay, 1 second. Okay, when I remove this to the side, all right. So we have everything in green, means that the joints are well done. I'm going to see just one of them. Edit, for example, that group. This is the solution. Sometimes when you start working with the software, the column, the wings of that column are not perfect. It maybe doesn't match with the beam who are getting inside. So you must upgrade the column. You must select different profiles. The same for this part. You see. On the bottom, if everything is okay, will be displayed a blue color, which that means that you don't have any mistakes in that joint. In order to get the better solution, you must get inside here, click inside, try to work on it. I recommend you to work first with these examples, and then you can start displaying information regarding to that ball with that connections. And the beams who are getting inside the knot, you will have a very well documentation about these joints. Also, you have a full report, well displayed. You can use it. You can customize also this kind of documentation. This is not a black box, you know. This is the beauty part of this software, because you can get a lot of information for you. You can support your analysis and designs. And it goes by the normative that you are working. If I'm going to the ACI, you will display here the same sections with that normative. If everything is okay, you can use this block. You can close it and save your job. Sometimes we forgot to do that. We forgot to do so, and we start a new calculations, a new analysis, and you lost your job. You have to log this sometimes, you know. I'm going to show you another one. Look, this is different. Same thing. You can get the drawings as well. The drawings are pretty cool, as you can see, well detailed. You can see sections in the groove. This joint has you can see it in four elements, and also the fastener elements that are displayed there. Let me finish. We go back to one on top on the roof. It's like this. Same theme, same drawings. These drawings you can send them to export to AutoCAD and do the modifiers that you require. Maybe that one is different. Look, it's different one. And let me see if I have this. Oh yeah. What I'm trying to tell you before, and I couldn't find the right word, is this condition pin end. The columns have a pin end on top, and that's why it's the only solution. If you check the joint, it will tell you that you need that condition. Let me see. Let me go back to, well, you can use this to go back. I know there are different joints. Oh, here. Here we have everything in red mark means that we have no solution. So try to displace, there is some mistakes over here, and we work it out. Fine, not this one, I think so. Well, this one is okay, but I click in the wrong place. That one. Oh, that's okay, this is the wrong side. You will see that these elements are inside the connection, inside the plate. They're supposed to have a different slope. We must work, and you will see on the left side to the bottom that they are displaying the mistake that we must work and try to make the solution. Let me show you one which is solved. For example, that one. Look, this is the right place, the right situation of that connection. Okay. The other one was a little bit inside the plate. This program is really picky. If you don't do it properly, they don't give you the green color. Also the plates, I want to show you the plates. And you can work in the plates. You can change the connection on top. You can do it welded, or you can do with a screw. You can change straight bars. And the bolts on top, you can change as well. You can change the plate, the size of the plate. You can create also some stiffness around the bar. See, it's really easy to work with. It's not very complicated to learn and work with the software. Let me show you the last one. I think so. That one, but it's okay. There's the knot, which is interesting me the most, which is like this. An extra information regarding to the how to articulate the knot. You know, the extreme of the bar. We have, especially for these solutions, which are the bolded connections. The articulation knot could be deserted to the case in which the really will be if the end embedment and rotational stiffness are used. Is it different from articulating an end in which the 3 degrees of freedom of rotation are released? We talked about that in the beginning, but when we define the embedment coefficients on the rotational stiffness, it's only acts on 2 degrees of freedom. The third ones, which is the rotation on the axis of the bar, is being prevented. That means that the rotation around the guideline prevented. As you know, guarantee then the perfect connections in this kind of joints is difficult, because means represents a lot of work in the factory, and also when you are displaying this in the real job. So we need to analyze that we can create some mistakes in between. When we are doing the rotational stiffness, that means that we are creating at least 20% of the original values that we are getting from the software. Suppose you do the first analysis of this warehouse, and the warehouse give you the effort and according to the load that you are introducing in the warehouse. But these solutions, if you want to go a little farther with these kind of joints, we must go for the rotational stiffness. Yeah, and that means a different condition, which is going to be 20% less. If you do that, the program will give you, if you are in that range, the program doesn't do anything for you. But if you are farther than that 20%, the software are going to warn you that is something wrong. I prefer to do it with the rotational stiffness, because it's a real work. Try to do it properly, and especially the embedded conditions, 100% accurate is difficult. But at least the program has that option, no, to do it by the rotational stiffness. Okay, what else? Okay, so this is it for this part, and now we go for the, suppose you have that job, this job, and that job you want to do it with the vertical frame generator, right? So what we need is just the basic. In the first example, the first one, this one. Oh, I forgot that one. Sorry. You go back to our example. We go back here. What we need to know is basically the frontal one. This information, the plane, Let me see. The dimensions show. Okay, we need to know accurate these conditions, the side, the length, everything, and forget about the rest of the structure because we need just the first frame, right? So now I'm going to work with the general particle generation. We go for new ones. Sorry, I'm gonna close this. I'm going to close because I opened several projects. I'm going to close it, all of them, right? Just to get one. Now I have one. Go for the structure ones. Particle frame generator. Okay, we go for new one. But we're going for dual pitch. Okay. We have type of roof, could be truss, could be Pratt, famous Pratt, the Warrant, well, straight, and so on and so on. Okay. The one on the last one, or the previous one, the treasure frame, we have this selection, but according to your drawings, the operate dimension work. If it's not like this, don't worry. You can introduce this using the same information. Just what you need to know is the right dimensions of the structure. Then when you finish, you can go in CYPE, remove these selections and introduce the one you have from AutoCAD. Okay, I'll go for the rigid one. This is an example. I'm not trying to do the previous one. Okay, just this is an example. But you can change. Your fonts is 12 by 12, here by 12, whatever section will have. You can do it. You can do it. If you click in the center, you go back to the frame, and you can delete it. You can also generate an equal frame, just one or two. Remember, just only one. I don't want that, so I can remove this. You can delete the frame. I can introduce one in the side. You click in the right side. I'm going to do the new frame, mono pitch. If it's 8, I'm gonna be maybe go for 7. Sorry, 7 in this side, and the other one could be 6 or 5, and maybe here 5. And well, I'm gonna change this for 6 to be more, consistent. So we have it here. Then you can click here and you can move the frame symmetrically to the other side. You can snap the frame to the other side, and so on and so on. Okay. So I'm going to continue with that. So then I will generate the project according to the program. The number of span is going to be 5 by default, and the distance between frames are going to be 5. I'm going to go for width and roof covering, which is the usual. The weights over here, remember we are working with this units, kilograms. I'm going to go for 30. About the external panel light load, well, it's 30, that's okay. With lateral covering, I'm not going to use the lateral covering. That's mean that one, the side rails. I'm not going to do that. but wind, I'm going to do it with wind load. With load, well, we don't have something in Indonesia, Malaysia. Well, maybe later, but we don't have that here. Maybe India. No, we don't have that. Well, suppose you are working in India. You can also send, if you have this information, you can send to us. I will introduce your wind code here. This is India. This is the basic wind speed. We go for the place. You can select that the city, the structure class. This is the we had an opening.
You can use American code for wind, Diego.
Over there? Okay, good. Let me show for the Americans. Right. Oh, good, because I can, by direction, I can show you better I can show you, this is the best example that I can tell you why we have a positive and negative wind conditions. Suppose the wind is the wind is
the one we use over here.
Ah, good. Thank you. Thank you, Vincent. Thank you, Vincent. Suppose you have a wind condition hidden in this side of the warehouse. So we displace this wind into with 5% of the displacement with the eccentricity, 5% eccentricity. That's why we have positive and negative. But remember, I haven't shown here that the wind conditions in Site 3D are different than the SciCAD. But it's not, it's well to know, you must know that. But when you are introducing this structure to SciCAD, the program are going to do overlapping those information, and they will get it straight. No, you don't have to worry because they do it automatically. But it's difficult to match because in this software it's very open. You can do any structure you want. Especially you can use it to very weird structure. And if it's not the case, I prefer to do it in. If you are talking about the domo, it's better to do it in AutoCAD because it's more. You get the precise disposition of the bars and points and joints, and also when it's well done in AutoCAD, you can export that to our software. It's going to be easier that way. So we continue with this. The wind condition going to be like that. Almost finished with this. Continue. Now we have it here. Now the snow load. Well, I'm not going for the snow. The limit state and the use category, I'm going to keep it that way. So now we continue with the edit late and roof purlins. You can use purlins on the roof and also on the site. So I'll go for the roof. So about the diffraction limit, this goes according to the normative. The number of span could be 1, 2, or 3. And the number of collaborating roof could be hook or rigid fixing. I go for the rigid fixing. And now the same section about the pooling descriptions. You have the type selections and separation and the steel type. The steel type, I think I'm gonna keep it. I don't know exactly what is your needs, but we go for the type selection. In type selections, we can maybe work with this, right? it's gonna be these properties, but I'm going to increase a little bit because maybe it's gonna be very small. Could be a single one, it could be double one. I go for double one, accept it, and I do the first design. Clicking this button, program are going to work with all the library that we have, and then I'm gonna give you a solution. This solution is in the range, is in the limit, so we can go for it. Accept it. Now it's here. The next section is the separation. You can do 1 point, maybe less, maybe 0.85. Now, you click design. Now, what is going to do the software is they're going to keep these type of profiles, and they're going to select the best options, the best separation, the optimal separations between the purlins. The designs accepted. Now software is working, and that to give you that the optimal separation is 1.10 and has been found. So accept that. And if it's not the right solution, perhaps because you already have in mind maybe 1 meter, but doesn't care. Put it one meter, and we are safe because you are the limit, around the limit. Accept that. And now the program gives you these checks, and this is a proof that you must keep separate because you have to support your analysis, and this is something really important to keep it somewhere. And accept it. You have now here, this is the separation between them. If something happened and using the wrong profile, you can do it. This is an iterative process. You can do again and again until you match what you need. Also, if the locations on top of the roof is not what you mean, you don't have to worry. Once you are in the software, you can do this discretization differently according to your program. Okay, we go for the dimension, purlins, and load wind conditions. Report the board. I want to check what is done. I'm going to view all the load cases. I can display here that according to Dynamati, we have all these for pressions and suctions. I'm going to view all of them. I remember that I chose to work just on the roof. Accept it. Look, this is what you are saving. It's a lot of work. Now we go back to the management and section library just to show you all the profiles that we have. You have in mind. Okay. And now we continue with the well, I'm not going to use that to export this. In order to export, I give you the last check of your purlins. In this last window, we must support the configurations. I go for the fixed frame, and about the backlink options. The most important one is that these two, but the backlink is non-sway frame. Well, if once we are doing the analysis by hand, you must define which conditions are going to be. We respect this condition only in this direction. If you see my cursor in this direction, we follow this direction because the program knows that in this there are some restrictions in this side of the warehouse, but in the other side in this area, in this vein inside, is not guaranteed. The backlink conditions, the software, if you choose this, are going to give you some alternatives. By default, you will get some information, but in the other side, we have to prove it. We have to check it because it's not. It's only proved in this side. Okay. The type of generation could be in 3D, and the last grouping options, I don't like to group them. I like to work myself and group, as you know, as I did in the beginning. I do the group selections, and that's the way I like to work. I don't like when the software do things for me. Accepted. General information about the exportations. Always say yes. And now we are into the program SYPE 3D. So we are opening the program SYPE 3D. Because this is an exportation, try not to change anything here, just accept it. Accept that. If you want to change this, that's okay. I'm gonna call maybe, I don't know, whatever, you know, doesn't matter. Doesn't really matter. No, look, so they did it for us. The first thing is to view. You see a different color. Just small bar in red. That means that we have no bar selection up to now. So we have to start working little by little until finish the warehouse. But what I want to show you is the load cases, the visible load cases. Look, all these are inside. I'm going to view it over here. It's a mess. And then we can go back to the program also. I created by default the panels, and also you can see the surface load. So if I'm going to edit or to view all the loads on panels, you have panels on top, because remember I told the program just to check the roof. If I'm going to check the entire structure like an opening warehouse, I will choose the other options, and it will get you the entire panels around the warehouse. So you click in one of them, right click, you will see the set load, the live load, and also you want to create a new one. You look, everyone is here automatically. You don't have to introduce here the conditions. By default, the programs are working inside and they note. If you need something extra, like a save load extra or live load, you can do it. But all these are already done inside the software. Okay, so accept that. Now we just start moving ahead, looking for the best profile. We already done it in the previous examples. One last thing that I can inform you or guide you is that, as you can see, the first seminar, we were working with SciCAD. There are certain interaction between software. The package will be a general particle frame generator, SYPE 3D, and SciCAD. I think this is the trinomial which is working very well. And sometimes it's better, depending on the job, which software are going to please you, know. Maybe depending on the job, you will better do it inside 3D instead of doing inside CAD, or both, both conditions, or three of them. And there is an option also that you can bring this software, and you can create all. You can start the foundation elements inside CAD. You can do the poles, or we call it small columns in concrete, and then the foundation elements. And And then you finish the entire structure here in the site 3D, and they can move on the structure to on top of the columns in SiteCAD. If you do it well inside 3D, you find all the solutions, joint solution, everything, profiles. You don't have to do it inside 3D, but if you want to do the foundation elements properly, you must run the analysis together. You know, you have to do it together, not separately, because you need to know what is inside the columns, what is in the beginning of the column, the foot of the column. So that's why we have to do it one more time. But you don't have to double check the metallic structure because you already done it. Okay. Okay. Apart from that, I would like to receive any questions. Okay, guys, are you gonna help me with the questions? If you don't have any questions, remember use our email and try to take advantage of the of the free services that we have. Technical support is free, doesn't have any cost. If you buy the software, you have it forever. It's not like the other software that if you call them, you have to pay. We called you, and also sometimes you have to arrange an appointment to get access to the technical support, and they charge you for that. You spend 1 hour in that technical support, they will charge you 1 hour. In our case, this is not the policy of this company. Okay. Okay, guys.
Diego, one more thing. Well, during this presentation, it was, well, we were also thinking to talk about the steel detailing, the StruBIM Steel. I think there's not enough time because, your explanation was very good, very interesting. I think everyone has understood the topics. Even the last part for portal frame generator was really nice. So maybe you can comment in a few minutes what's the StruBIM Steel, what's for, or what is doing. And there are some questions already. So about the forms, we have recorded the session. If you have any other questions, please write in the chat or in the question chat. And go, if you want, later you can read the questions. Okay.
Yeah, sure. Go ahead.
Where is the question?
I don't see any question.
I don't see any question over here.
Yeah. Well, Diego, maybe while people makes questions, can you explain a little bit the new StruBIM Steel and the connection with SYPE 3D and so on?
Yeah, let me find out 1 second. I'm looking for that information.
Well, and I use this time to remember you, as Diego said at the beginning, we have launched a new software that is called SYPE Architecture. The idea is a software that is similar to other architectural software. But the interesting is that here you can see that you can use SYPE 3D to model, but also you can model in SYPE Architecture. Maybe it will be faster over there, depending what you want to do. If it's a very complex steel structure, maybe it's best you do the design in SYPE Architecture, and then you will be able to import all the information here in SYPE 3D and analyze the project, and then export the information to StruBIM Steel. That is the software that I'm talking now about. That is also another software for steel detail. So you will be able to do the joint detailing, the connections, and so on. So next Thursday, there will be a presentation in Indonesian language about architecture. So I also recommend all of you, even if you are civil engineers, that topic will be also interesting because, as I said, you can use that software that is free to do the design and then import here inside 3D and get the analysis.
Diego, can you show the report generator over here without showing all the details? That may be very good.
CYPE Steel. I'm looking for CYPE Steel.
It's called StruBIM Steel.
StruBIM Site 3D.
No, StruBIM Site 3D is Site 3D. It's StruBIM Steel.
Yeah, I got it. Okay, I'm gonna show you this. This is StruBIM Steel. You can download it from here, right? From here, and the program. Let me check. Program is this one. StruBIM Steel. Creation of a new. Well, I don't have in English. I think so. I'm not sure if I downloaded in English, but I will show you right away.
Well, you can show an example because we are running out of time, so don't worry, Diego. You can show an example. This is a free software, this version, because it's a very new, a new software. So I recommend all of you to download both this one, StruBIM Steel, and also SAP Architecture. We are implementing many new joints every week, so now you can find many already, but you will be able to find much more. If you are looking for something else, you can also send your suggestions, and we will try to implement your idea.
Yeah, this is the department that is growing very fast right now. Is the most important one. They are looking for best solutions. I think the beauty of this software is that you can get a file that could be sent to the fabricator. Well, later on, you will get more joint solutions. Could be any solutions. It's difficult to do this. They're working very hard to get it. And as I told you, you can start with you can find solutions inside 3D about the joints. If you don't have it because we have some restrictions inside CAD, you can move on to Site 3D. Once you cannot find the solution inside 3D, you can go to Site Connect. If you don't have that solution in Site Connect, you can come here. Finally, for sure, you will get a solution. It's pretty cool. I'm learning to work with this software, but it's pretty cool.
Maybe you can show Diego how to change the elements in the joint, or
well, no, not yet. Yeah, this is different.
I think
look.
Yeah, if you click in the plate, it will let you modify it, I think.
Let me check. It's really hard to touch it now. Okay, look. This is the plate. You can work in the plate. You can generate the polygonal, the materials. You can hold the modifications. You can. This joint is going to be with 3 different elements. This is one. This is another one. The one on top is completely different. It's double T element. So it's later you will have any joints, right? And you go by levels. Let me check this one. You have the polygonal, you have the type selections. There are drilling size. This is the drilling, the diameter, and the directions. These are drillings, okay? Well, I will show you a list maybe next time.
Are there any other examples? Anyway, I think people understood the idea, no? Maybe in another session we can focus on this. well, the idea is you do the design in SYPE 3D and then you import it here and you do the detailing. Some people is asking questions. Diego, do you want to ask you or you want to
Go ahead. Go ahead. No, go ahead.
Okay. Okay. Some people is asking about the seismic options because in Indonesia is a must. Can you tell us something about that?
Okay, good. Well, we are doing it. I'm going to this place. Maybe I'm going to help you with this program. 1 second. For the dynamic options, we introduce this normative. You are following the Americans or? No, we don't have here. Well, could be American. No, Malaysia. We have Malaysia here, right? We are applying the Eurocode 8. Well, you can arrange wherever you might need about the analysis and about the parameters, the structural systems, the location data, and also the soil type. But you need to know basically that the program do both analyses, the metallic one and the dynamic analysis. In the SYPE 3D, we define the hypothesis. We assign the load cases that you already know, the bars. We didn't talk about the sheet, but they are inside the software. And we can introduce the hypothesis like any other software. About the dynamic analysis.
They are saying that in Indonesia they may use American instead of Malay. I don't know how similar it is.
That one, yeah, you click that one, see how? Is it this one or that was what we use over here, the ASC 716, we use it over here.
Good. So we have it. So we can follow all the selections. But about the dynamic analysis, we follow the general method. We call the Modal spectral analysis. We need to know the accelerations, the ductility of the structure, the number of modes calculated, and also the coefficient or quasi-permanent coefficient overloaded, and also the spectrum acceleration that we select here. Look, the design spectrum is introduced here according to the place that you are working. I can tell you many things about this. The other day I explained this in South America for one of the conference in South America, and I was on almost 1 hour explaining this. But if you need information regarding to that, I have the document in Spanish, and I will give this information to Vincent, and he will translate that to you guys. But it's well explained the way to do it. What else I can tell you? We create, for example, a mass matrix according to the program, and we do another mass stiffness of the structure, and we combine this mass matrix and the stiffness matrix according to the hypothesis that we are doing about the dead load and the load and dead load. The corresponding overload multiplies this by the coefficients of quasi-permanence in SYPE 3D, and they integrate all these matrix mass coefficients concentrated in just in one side. Well, I think the number of solutions that we get in the software are equally about the number of the dynamic liberations that are assumed in the software. And it's difficult for me to explain you in English because I have it in Spanish, but I will give you this document for all the guys who are interested to know what we are doing inside the software. About this secondary effect, there is something really key to tell you, that we are doing the linear analysis, and this method, the P delta method, we are the number that we have to introduce here, we go by number 1 or number 2. Number 1, we can display the number 1 just for the metallic structure, and number 2 for the concrete structure. There are some cases that wind conditions are more critical than the concrete ones, so it's better to do this analysis with this method. This is a secondary method. It's something interesting to analyze, and it will get you every country. We give this number up to the users. You as a designers, you must find out which number you are going to introduce. I know that countries like Brazil, they know right away which number they are going to introduce. They use 1.56 figure, and but you must understand that it's between 1 and 2, doesn't go farther than this value. For concrete, for metallic structure, I better run and use the secondary order effect. Remember that you must select the type of soil, the risk category, and the number of vibrations mode considering in the analysis. Could be based by the code, could be automatically. In this case, we are using by default 90% of the mass excitation, but you can load it a little bit, about 80% is up to you to display this. And the specific by user is loaded by default number 6, but in reality, we are taking consideration just 3 in the X direction, Y directions, and 1 rotation. The last one, the effect of the vertical seismic components. We follow the American normative. I have especially another document for that. As I told you, I will give this information to Vincent. He will translate that in our department. Could be available for you. But we follow what is in the American code for the vertical load. What else I can tell you about this? Yeah, I think this is it.
Okay. Did you finish, Diego? There are some other questions.
No, I forgot to tell you about the structural system, the response modification coefficients, and these deflection amplification factors. These values are the engineer has to know according to the normative. You must find that in the code and introduce it here. It's not automatically. About the redundancy factor, we are introducing this number 1. You are safe if you follow with this, but it's the user who are going to do the right selections according to this redundancy factor. I know that the internal the department, there is one department who take care about this. In that department, they are working ahead, looking for to do it automatically. I know there are some normatives like the Americans and also in South America what the seismic effect is very important. The redundancy factor are so important to develop inside the software, but not all the cases are available. I know for sure that part of the information you can get in the software from our software, but you can take from here and there some values and continue with your hand calculations in order to get these boundary factors. I think this is it for this. And also, you have the specific by user, and by user you need to introduce the spectrum. I don't know if I have we don't have any example here, but you can introduce the spectrum. If you have it in Excel, you can come here, introduce it, do it by yourself. All right.
There's one person, Diego, asking about just this, how to create the response spectrum analysis. So I think you already explained it, right?
Okay, good. Yeah, like that. Okay.
Okay, so you already answered that. Okay, there's another question. Is saying that a user was downloading the software and he's testing the software, and he said that he has tried to import the CAD drawings to do the design. He's asking if he has the CAD drawings in 3 dimensions, how to import if it's possible.
Yeah, good. Listen, okay, let me check. Let me look for one of those. Give me 1 second. Well,
I think for the demo of importing from the CAD, that can be done in the next seminar, probably next webinar.
Yeah, why not? But I have here. The thing is, that one. I found it. Don't panic, okay? Good. Look, this is the 3D. They did it. This example they did it inside 3D in AutoCAD 3D. You know, try to do this in our software is really a pain in the neck, you know. But once it's here, you can start working very fast. You can do anything you want, anything you need. You know, your limitation is your imagination. That's the only limitation in this software. Okay, the limit is your imagination, but it's possible. You have another question? Do you? Vincent?
Any other further questions?
Vincent, Vincent is not here anymore.
All right, probably he is offline. Kepada I will speak in Indonesian now. Kepada para peserta webinar, kalau ada pertanyaan bisa juga dialamatkan ke saya. Nanti kita berusaha menjawab atau nanti diadakan webinar berikutnya untuk menjawab pertanyaan-pertanyaan yang ada. Jadi kebetulan saya, Go Chi Leong, itu ditunjuk menjadi agent untuk site structure-nya mereka, termasuk site CAD, yang untuk desain arsitek, dan itu pada dasarnya bisa diimport dari AutoCAD ataupun MicroStation, itu juga bisa dari Revit. dan diimport lalu masuk site 3D, kemudian dari site CAD, dari site CAD bisa dirapikan kalau perlu, masuk ke dalam baru masuk ke dalam site 3D, dari site 3D bisa masuk ke detailing, jadi mereka juga sudah provide detailingnya, join daripada structure termasuk juga di dalam concrete analysis kalau beton, ya bagaimana detailingnya. Terus detailingnya bisa dibuat dalam report, udah termasuk dalam gambar-gambar. Tentunya detailingnya juga bisa diubah bila mana tidak sesuai dengan apa yang kita inginkan. Begitu, barangkali bisa hubungi saya di gtloffice@gmail.com, ya gtloffice@gmail.com, atau bisa juga via WA, ya, di 0816 806649, 0816 806649. Kita akan coba menjawab. Jadi kalau ada, pada dasarnya saya mempelajari software ini karena saya juga bukan structural engineer, tidak terlalu jago di situ, tapi dari pengertian saya ini bisa membuat segala hal yang tidak kalah dengan software-software yang ada, dan bahkan dalam reportingnya dan detailingnya jauh lebih bagus. Cuma saja dan mereka ini belum populer gitu ya. Terus juga software ini bisa menggunakan API code dan American code, dan kita juga bisa memasukkan, kalau rajin bisa memasukkan SNI kita juga ke dalamnya. Ya, begitu. Barangkali ada pertanyaan lain. Silakan ditik di chatnya. Vincent, are you there? Diego, I think if there is no further question, probably we can end the webinar right here.
Okay,
then,
let me show you the last example. Take a little while. Yeah, you can do bridges. You can do, let me see, in 3D. You can do domos. You can. Oh, this is the foundation for one of them. What is not showing? Okay, good. Look, something very different, complete, different shape, different roof can be done with the software. Okay. Even in this software, you can do the foundation analysis. Yeah, I forgot to introduce you to that, but it's possible. This is called Shave. Is making concrete. Also, we are using different profiles, foundation solutions. I think that's it. Okay, guys, thank you very much for your assistance. I appreciate that. And maybe I will see you in another conference next time. And okay, thank you very much for your.
Thank you, Diego.
And you're welcome. I hope it's gonna help you a lot. Bye bye for now. Bye bye for now.
Ya, bye bye.
Okay.
Okay. Thank you.
Okay, thank you. Take care.
Kepada semua peserta, mungkin kita akhiri di sini. Seperti saya katakan, nanti kalau ada yang ingin ditanyakan bisa via saya, ya lewat email. Sekali lagi emailnya adalah gtloffice@gmail.com, gtloffice@gmail.com, atau juga ke WA, ya WhatsApp 0816 806649. Oke, terima kasih kepada semua. Kita akhiri sampai sini. Alright, Diego, you can close the meeting.